Hello everyone, myself Praveen from third year integrated MSc Physics. I'm here to show the division of two 16-bit number in 8085 microprocessor. Basically, we will use the simulator software to perform the division task. My PPT include the content like algorithm, the flowchart of the program, and the program itself. Now, before coming to flowchart and algorithm, I would like to make 2 points here. The first one is as 8085 is 8-bit microprocessor, so we will use the register pair to perform the 16-bit operation. And as there is no such direct command of division in 8085, so we will use the successive subtraction method to perform the division task. Now coming to the flowchart. First we will clear the BC register pair and we will use it to hold the quotient. Now we will use the D register pair to hold the divisor and HL register pair to hold the dividend initially, and after that we will use the HL pair as a remainder also. Now coming to the subtraction part, we will use the 8-bit subtraction here because we will perform the subtraction in accumulator and accumulator is a 8-bit register. In the subtraction, what we will do, we will simply subtract the HL from DE and updated the HL. Now in the subtraction we will check if there is carry or not. If there is no carry, then it will increase the value of BC ratio pair with 1 and come to the loop step again. And here it will again subtract the E content from L content and D content from H content, and after that it will update the HL content. So again we will check there is a carry include or not in subtraction. We assume that there is no carry involved in this iteration also, so it will increase the value of BC pair with 1, that will eventually become 2 and it will come to the loop step again. Now again the subtraction will be performed and it will update the HL, but assume that there is carry involved in this step. Now in this step it will come out of the loop, and as we want our HL register pair to act as a remainder, so basically to hold the remainder content in HL pair we want that. So for that we will add the HL content, that is our last iteration content, with the DE, that our divisor content, to the HL, and after that we will end the program. But the point I want to make here is we can understand it in a little example here, like our HL, that is our dividend, which is 5, our DE, that is our divisor, which is 2, and BC, that is 0. Initially these input are given to the HL, DE and BC register pair. Now to perform division we will successively subtract the HL content and DE content from DE content, that we will subtract the 2 from 5, that will become 3. As we can see there is no carry involved in here, and so we will increase the BC value with 1 and come to the loop step again. So we will increase the BC content with 1, and after the subtraction will be performed again, so it will become 1, and we will check there is carry or not. Yeah, there is no carry involved here also, so it will increase the BC again to 2, and now we will subtract the HL from D content here, 1 from 2, like it will give -1, but we will see that there is a carry involved in this subtraction because it is lesser than this. So we will not go to this loop again, we will come out of the loop and the BC register pair will hold 2 only. So at the end we want the our remainder in HL register pair, so we will add the last iteration value of HL to the divisor, that is -1 plus 2, that will become 1. That is the true remainder here, not the -1 here. The remainder here will be 1, so that action is performed here. We will add the HL and D. Now coming to the programming part, I have input as 0202 as a divisor and which is stored in D raised to pair, and my dividend, that is 0441, that is stored in HR raised to pair initially. So I'm going to the simulation software. So here we are. So I have written the same program here, and we will do the division task here. First, we will assemble the program here. Now the program is assembled successfully. Now we will run it step by step. So to the first step, it will run. Yeah, it's running. Okay, that's fine. Now coming to the jump start, that is unconditional jump. It will jump to the start label here. In this step, we will load the PC register pair with 00. So we will load the PC register pair with 00. That is our quotient. It will act as a quotient. So we updated the PC register pair with 00. You can differentiate here because it was already 00. So to the next step, here I will upload the 8-bit data to D and 8-bit to E, that is our divisor, that will become 16-bit after the updating the D recipe here. We will use the MVI command that will directly move this 8-bit data to the D register. So you can see that there is immediate updation of D register here, that is updated with 02 data. The data here are in hexadecimal. And now we will update the E also. Similarly we will update the H and L register also. That is, so we have made our divisor as 0220 and our dividend as 0441. Now to perform the division action, we will perform the successive subtraction. That is, the L content will be subtracted from E and H content will be subtracted from 2. That we will make a loop here. First, to perform that action, we update the accumulator with this value. So we will send it here and subtract it from 20. So it will become 21 in the end. So it has become 21. And the same with the H content also. Move to accumulator and now it will be subtracted. That has become 2. Now we can see we have come to this step here, jump to skip if there is carry, but we can see there is no carry here also. You can see there carry flag is 0, so this step will be not be performed, and we will come to the next step, that is increase B. So it will increase the B. As we can see that there is one loop is performed and we will increase our quotient to 1. Now to the jump loop, it will jump to the loop step here. Now the same subtraction will be performed, that is HL content will be subtracted from DE content and HL content will also be updated after the subtraction. So the subtraction is performed and the operation is done. Now coming to that step again, jump to skip if there is carry. Again we can see there is no carry though, so it will not jump, and we will perform the another step here, that is increase B. So it will increase B to 2. Now it will come to the loop again, jump to the loop, and now the same subtraction has been performed. But you can see here that there is inclusion of a carry here, like carry flag is 1, so we can say that uh, carry is included here. So in the jump condition, jump to skip if there is carry, so it will jump to skip label here, that is our DADD, which means we will eventually add the HL content to the DE content to make it a remainder. So it will be updated in HLA, that is 0001, that is our remainder is 01. And come to the exit, that we will exit the program. So in this program we can say that our BC, that was our quotient, it has become 2. That is our, now we can say that our quotient is 2 and our remainder is 1. So our output is our 02 and 01, that is quotient and remainder respectively. Now to cross check that program, I'm using a internet hexadecimal and calculator, that is to divide the two, our 0441, that is our HL pair. Initially that was our 0441 and our divisor is 0220. And check here, we can see that our quotient is 2 and our remainder is 1. That's the right here. We can say that our program is right. Now that's all. Thanks.